Hello again. Today I'll show you some easy calculations in eighth. In the first place, I have to say a bit about infix notation. Infix notation is the notation you have used in school. And infix means that the operator, the plus in this example at the right hand, that the plus is between the operands, the 2 and the 3. In eighth and in all fourth dialects we use postfix notation. Example 2, 3 plus. The 2 and the 3 get entered on the stack, and then the plus takes the 2 and the 3 from the stack, evaluates it and puts the resulting value back. So when I do that at REPL, I'll first enter 2 and 3 and show it to you. Okay, 2 and 3 are on the stack. Now I issue the plus, and now I'll show you the new stack contents, and you see that the result 5 is now on the stack. All other calculations are done in the same way, as we'll see later. So it's very important to remember always that it's the other way around. It's not infix, it's postfix. Now in eighth we can enter such expressions differently. I'll first reset the stack and I'll show you. When I'm gonna add 2 and 3, in the previous example I put in 2 and 3 first, entered it, and then entered the plus, and then entered the .s. But eighth doesn't matter. Eighth looks at the white space delimiter and really doesn't matter. So I also could have done this: 2, enter, 3, enter, plus, enter, .s. Exactly the same result. Also we could have done 2, 3 plus .s at once. So that's easy. So you can have a calculation just in one sentence and put up the result. Of course there are more calculation operators. So for example the minus. I'll show you an example of minus. In the previous examples I used reset to clear the stack in between, but that's not really needed. I'll show you. We're now going to subtract 20 from 24. So 24, 20 minus .s. And now you see what happens. The 4, the result, is at the top of the stack, and below that is the previous result, which was still on the stack. But that value really doesn't matter for the minus operation. In the same way we can multiply. For example 6, 5, asterisk, .s. And again you see that at the top of the stack the result of 6 and 5 is present, and the previous results are below it on the stack. But that's no problem. In the same way we can do a divide. For example 100 divided by 2 equals 50. Right, it's at the top of the stack. And the other values are still on the stack, but that's no problem. In a real world scenario we'll have more than one thing on the stack, because there are nested operations going on. In the end the stack should always be clear. So you have always to keep in mind what's on the stack, and that's the most important thing to remember when you are trying to debug a program, that always what's on the stack should match your expectations. There's a last word to say about calculating easy calculations. That's called operator precedence. In most programming languages there is an impressive chart of operator precedence rules. And that chart tells you exactly in what order the programming language evaluates expressions. In school you also learned these rules. For example, multiplication should be done before adding, and so on. In 8th we really don't need such a chart because it's clear. On the right hand side I've got this expression where I'll show that. 24, 8, 2, divide, minus, 3, 4, multiply, plus. And it's really evaluating from the left to the right. So it just takes the operator slash, the divide, and divides 8 by 2. That's step 1 of evaluation. So then there is a result on the stack 24, 4. And the resulting expression is 24, 4 minus 3, 4 plus, 3, 4 asterisk plus, and so on. It evaluates step by step from left to right. And there's nothing to it. If you just put the numbers and the operators in the right place, it will also always do what you want. So there's really no problem. I hope you've learned a lot in this lesson and we'll come back to you later. There's much more information about 8th on its website, which is called www.8th-dev.com. Goodbye for now.